Hi everyone, for today's lesson we are going to start our next unit, which is called Unit 3, Introduction to Proofs. Today's lesson, Day 1, is about parallel and perpendicular lines and conditional statements in if-then form. What you see here are the symbols for parallel and perpendicular. So these are the symbols that I want you guys to associate parallel and perpendicular lines, as well as a new kind of statement that we are going to be working with called a conditional statement. And conditional statements will be written in if-then form for this class. Our learning targets for today is for you to be able to say, I can define and identify characteristics of parallel and perpendicular lines. You guys learned about parallel and perpendicular lines when you were in Algebra 1, and now we're going to connect it to geometry. Then I want you to be able to say, I can identify the hypothesis and the conclusion of conditional statements. And finally, I can write conditional statements in if-then form and write the converse of the conditional statement. So we're going to learn a lot of vocabulary words in this lesson. We're going to learn more about parallel and perpendicular lines, hypothesis and conclusion, conditional statement, converse of a conditional statement, and what if-then form actually looks like. For today's lesson, you will need glue or tape, scissors, some colors, something to write with, and our cutouts for today. We had a blank piece of paper. We had terms being parallel, the parallel postulate, perpendicular lines, and the perpendicular postulate. And finally, additional terms about counterexample and information about counterexamples. So please make sure that these cutouts are cut out and ready to go for today's lesson. Let's get started. The first thing I would like you guys to please take out is the cutouts about parallel lines and the box that came just below it. I would like you guys to please go ahead and paste this table directly into the center of the rectangle. And we're going to create a very similar cutout that we have in the past. What I would like you guys to please do is please go ahead and cut up all the way up to the line of the term on each side so that we can have tabs. Go ahead and start off with our first vocabulary word. Our first vocabulary word is parallel lines. Parallel lines are two coplanar lines, meaning that they lie in the same plane. So this is very important. Two coplanar lines that do not intersect. So parallel lines, please go ahead and draw two lines that do not intersect. What you're going to notice about these lines, we'll call them M and N, is that they are going in the same direction, but they are not intersecting each other at all. To show that lines are parallel to each other, similar to when we wanted to show that segments were congruent, the way that we show in geometry that lines are parallel to each other is we put in arrows into the center. So in the center of our line, you're going to see these arrows. The number of arrows are going to indicate whether or not lines are parallel to each other. And what we would say, a statement that we would say is we would say that line M, we would call it just little m, is parallel to line N. Our symbol that looks like a really, really tall number 11, this represents the word is parallel to. That's what the symbol means. It looks like a really tall, skinny 11, and it represents the word parallel, is parallel to. Line M is parallel to line N. The parallel postulate says that there is exactly one line through point P and is parallel to line M. So what that means is that if I have a point and I call it point P and I draw a line going through point P, there exists exactly one line going through point P that is parallel to line M. So here is line, this is line N, and we'll call this line M. So if you have a point and you have a line going through that point, there only exists one other line that goes through P that is parallel to M. And we would put in those arrows indicating that they are parallel to each other. So arrows could be one arrow, it could be two arrows, but once again, it's going to be a matching game indicating that lines are indeed parallel to each other. This word postulate, this is called parallel postulate. And a postulate is simply a true statement. A true statement meaning that all mathematicians have agreed that this statement is true. There is no other way of putting it. There doesn't exist a way to say that it is not true. So therefore, all mathematicians say that it is true. The next one that we have is perpendicular lines. Perpendicular lines are two lines that intersect to form a 90-degree angle. So it's two lines that intersect to form or create a 90-degree angle. And we know that 90-degree angles are right angles. They are right angles. So what you're going to see is a picture that's going to look like this. We have one line going in one direction. We'll call it line A. And you have another line going in a different direction. And together, these two lines intersect to form a right angle. So you're going to be looking for that right angle symbol every single time to indicate that these two lines are indeed perpendicular. And the way that we express a relationship of perpendicular is we would say that line A is perpendicular to line B. So this symbol of an upside down capital T represents the words is perpendicular to. So is perpendicular to. We'll zoom in so you can actually read that. Is perpendicular to. And what you're going to notice is that there's going to be a lot of symbols that will represent words in this unit. So I want you guys just to be open to the fact that there will be symbols and to study what the symbols represent and the language that they represent. This symbol right here of angles, this represents an angle, the word angle, right angles. This symbol is used a lot throughout this unit. Finally, we have the perpendicular postulate. And the perpendicular postulate says that there is exactly one line through point P and is perpendicular to line M. So here is line M. Here is point P. There exists only one line that could go through point P and be perpendicular to line M. Only one line that is possible. And it doesn't matter where point P is. There's only one line that is perpendicular to line M and goes through P. And that's the perpendicular postulate. Please go ahead and fold in your tabs. Our first one was called parallel lines. And I put in that symbol once again of parallel. We have perpendicular lines. I'm sorry, excuse me. That was the... Excuse me, this one was not perpendicular lines. This one was parallel postulate, sorry. Got too excited. This one down here was perpendicular lines. And this was the perpendicular postulate. The whole point of why we talk about parallel lines and perpendicular lines just like this in geometry is because we need to know information about parallel and perpendicular lines to help us understand and prove statements in geometry. Because that's what we're heading. We're going to be proving statements are true in geometry. Proving that these two angles are right angles, or proving that two shapes are congruent to each other. There's one more thing I want to talk about when it comes to parallel and when it comes to perpendicular lines, and that is that the shortest distance so that is the smallest distance between any two lines is a perpendicular segment. So what that looks like is if you had two lines, one going this way and another going up this way, they're just two completely different lines. You can call them A and B. The shortest distance between them is a perpendicular. So if you were to imagine drawing a perpendicular line where you have a 90-degree angle and a 90-degree angle, it's a perpendicular segment. That is the shortest distance between any two lines, is a perpendicular segment. You'll see perpendicular symbols, or what I mean by perpendicular symbols is you will see a right angle, and whenever you see a right angle, that indicates perpendicular. So if you see a right angle, then the rays or lines or segments, I know I put a bunch of ors in there, are perpendicular. So you always want to look for that right angle symbol, like this. These two rays would be perpendicular to each other. All right, let's go ahead and move on. So that was perpendicular lines. And now we're going to talk about a thing called conditional statements. So a conditional statement that is a logical statement that has two parts. So it is a logical statement that has two parts to it. Logical meaning that it makes sense, it has a beginning, and it has an end. And the two parts are the if part and the then part. The if part is also known as the hypothesis. And the then part is called the conclusion. It is the phrase, the hypothesis is the phrase that comes after if. And the conclusion, that is the phrase that comes after then. An example of a conditional statement is this. If an angle is a straight angle, then its measure is 180 degrees. The phrase that comes after if is an angle is a straight angle. So this piece right here, this phrase that comes after if, this is known as the hypothesis of the statement. It's the part that comes after if. The information that comes after then is its measure is 180 degrees. That phrase is known as the conclusion. That is the conclusion of the if-then statement. So we're going to be working a lot with if-then statements, dealing with mathematics. So if two lines do not intersect, then they are parallel lines. If two lines intersect to form a 90-degree angle, then the lines are perpendicular lines. If, and then. Those are our conditional statements. Now, not all conditional statements are true. A lot of times conditional statements are false. And when they are false, you have to say so. You have to prove why they are false. And that's where counterexample comes in. So please go ahead and take out the next set of vocabulary words, which is counterexample. And what I would like you guys to please do is please go ahead and put this kind of on the side so that we can write some text. And what a counterexample is, it's a counter. Counter means against or backwards. So counterexample means an example that's against what you're trying to prove or say. So it's like a negative, or counter means against. And against what you're trying to prove. It's an example, so a counterexample can be words or a picture or mathematics, something that shows that the conclusion of your conditional statement is false. So what you might see is a conditional statement that says this. Let's talk about two different things. How about this? If you are a student in Mrs. Olivero's class, then you are learning math in her class. This statement is true. And that's because I don't teach any other subjects other than math. If you are a student in Mrs. Olivero's class, if you're enrolled and I am your teacher, then you are learning math from her. That is absolutely true. I am only a math teacher. I am nothing else. But here's an example of something that is not true. If you are a student at PSAP, then Mrs. Olivero is your teacher. This is false. Why it's false is, yeah, you might be a student at PSAP. It's not about the hypothesis. It's about the conclusion. I am not everyone's math teacher. I did not have all of you who were in my class last year, for example. There are several different math teachers at PSAP, and all you have to do is name one teacher. Name one student that you know of who does not have me as a math teacher. So name anybody that you know. So I might say a student that I had last year. I don't have him as a teacher this year, or as a student this year. So he is a student at PSAP, but I am not his math teacher. I can name other students. So all you need to do is name one student that goes to PSAP, and which I am not their math teacher and have never been their math teacher. So name one student. Name one friend. Who does not have me as a teacher. Because by naming one person at PSAP that doesn't have me as a teacher, you are making this whole statement false. All it takes is one. And that's something I want you guys to really know. You only need one counterexample. Because if a statement is true, then it has to be true for all cases. All students at PSAP needs to have me as a math teacher. But that is not true. All you need is one. If it is true, then it's true for all cases. As soon as you prove that a statement does not work for one case, then you have to say automatically that the statement is false. All you need is one example, and boom, the statement is false. I don't need many examples, and trust me, there are many counterexamples, but all you need is one. Only one. And then that's it. The next word that I want to talk about is a word called converse. The converse, which kind of sounds like reverse, and reverse means to go backwards. The converse of a statement is rewriting the conditional statement. So rewriting means writing again. Rewriting the conditional statement by switching the hypothesis and the conclusion. So switching, meaning that the phrase that was once the hypothesis becomes the conclusion, and the phrase that was the conclusion becomes the hypothesis by switching or reversing the statement. So some people might say, well, what about that last statement about Mrs. Olivero? If Mrs. Olivero is your math teacher, then you are a student at PSUP. That is absolutely true because I only teach PSUP students. So that's a true statement. The converse of this would be true, but the way that it's written would not be true. So converse is switching. So for example, let's say that we're looking at the statement, if an angle is 68 degrees, then it is an acute angle. In this statement, an angle is 68 degrees is our hypothesis. And the phrase, it is an acute angle, that is the conclusion. The hypothesis and the conclusion. So what we're going to do is we're going to reverse it. But please be careful. In this original statement, an angle is the subject of our sentence. Right here, angle, that is the subject of our sentence. And we always start off our sentence with our subject because it is representing the angle that we've already established at the very beginning of our sentence. This is the pronoun for angle, which is our subject. So whenever you write a converse, please make sure that you are identifying what the subject of the statement is. Don't start your sentence with if it is an angle, an acute angle, then its measure is 68 degrees. That is not what we want to do. Our converse of the statement means if an angle, there's my subject again, is an acute angle, Look at there. That's my green. That was my conclusion. I switched my hypothesis and conclusion. If an angle is an acute angle, then its measure is 68 degrees. Then its measure is 68 degrees. If an angle is 68 degrees, its measure is 68 degrees. Now, there is me switching my hypothesis and my conclusion. And let's go ahead and analyze this. Is this statement true? If an angle is an acute angle, then its measure is 68 degrees. Is that true or false? Well, in this case, it's going to be false. That's not true. Are all acute angles 68 degrees? No, not at all. Give a counterexample. And a counterexample is an acute angle could be, how about 70 degrees? An acute angle could be 70 degrees. So my counterexample is 70. Maybe you were thinking in your head a different number. That's a great number. All you need is one. One counterexample to say that if an angle is an acute angle, then its measure is any number or that's in between, or any degree between 0 and 90. That's really what this statement should say. But because we're just identifying or working with converses or reversing our angle or reversing our statement, that's all that we would say. So please, please, please be careful whenever you are writing converse statements. Make sure that you identify what your subject is. We are switching the hypothesis and the conclusion. And whenever you're providing a counterexample because a statement is false, you only need one. That is the end of today's lesson. If you have any questions over anything I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.